This is our app overview for our ENG6 project. This is group 57. Here's our main app, and here's the ThingSpeak transmitter. So let's start by generating a new table. It generates a random table based on the work Warren has done. So let's start selecting all the vessels. It shows the table down here and individual ships here. If you want to change their color, can. With the drop-down menu, we can choose a vessel to monitor their speed and their collision. So if we adjust the speed alarm to higher than their speed, it won't make that beep sound and the speed alarm will be off. If there's a collision, which means that the ships either collide or they are in range of these coastline buoys, then the collision alarm will go off and a small explosion sound will play. Alright, now that is done, we'd like to talk about the transmitter. So we can type in our own values if we like, but we can also generate defaults. So it's a little easier. And we press transmit. We have to wait until these are ready to load and it has been fully transmitted, which will happen when all the lights turn on, so I'll wait for that. Alright, now that it's ready to load, we can load vessel data, load from ThingSpeak, and a couple other features I want to show is you can show just one vessel. You can show two, show these two, show three, and they maintain their position. You can change the colors with the ThingSpeak ones if you want, and you can select the vessels and set the speed limit. And you can mute the sound and unmute it if you want. And that's it. That's all for our app. And now onto the code.
Alright, my name is Warren Miller. I mainly worked on the table generation code, so this one essentially just initializes the table that's used, that is displayed in the actual app itself. So we construct from a CSV file, we construct a base table, and then I also input the data types. So that's what those two detect import functions do. And then after that, we just randomize vessels, so that's another function. For each of the constant aspects of the vessel, is in like the length, the height, and the width, things that don't change, the name and the MFStat. And that's how this is what this function randomizes. There's a few different sub-functions in this, just to compartmentalize it. I know Nicholas helped with some of these names and stuff. He did other names. I just kind of modified it a little bit to work with my table. And then, yes, this is the ship heading, so it gives you a initial position and destination, and it basically finds the angle between those two things in terms of 1 through 360 degrees, like a heading of a ship would be in real life. I think that's how they measure it. It basically just normalizes the distance vector from that, and then it uses tangent to calculate that, the heading. Yeah, so each of those, the past position, the time, and the speed over ground, and the headings, those are each, technically it's a 1x1 cell array, which itself contains a normal array. I don't know why Matlab has it done like this, but that basically contains a list of all the positions that the ship will go through, and corresponding to that, the times at which those positions were reached and thus transmitted, and then also the speed over ground at each of those transmissions, and then the headings at each of those transmission times. For the speed over ground, the heading, you don't have a value for the first one just because you need two values to calculate it, so the first one is empty there. But other than that, it corresponds with data. It corresponds with data that would be calculated from the position positions that the chip had gone through.
Hi, my name is Nicholas, and this is the GUI section of our code. We start with a startup function that turns on the map at the start of the app, so it's not just blank. We have this, which is the menu selection for which vessel to monitor for speed and collision. This is the load vessel data section, so if you generate a new table, it creates a random table based on this run script that Warren created. Otherwise, you can load from ThinkSpeak, and it loads the table data from ThinkSpeak from the transmitter. This is the checkbox. So if you check a certain amount of these, or which one you check, it turns on a visibility value for which vessel you choose, and we'll see that later. These are the drop-down menus to select which vessel color you want, giving an RGB vector. This is some of the buoy data that we'll talk about later. Let's start with these. These are errors, so if you press start tracking, it will say please load vessel data and please select vessel to track. So if you haven't loaded any vessel data, or if you haven't selected any of these, it will give you these errors. Otherwise, you can select them and load vessel data and it will work. These are the loading the coordinates from the tables, either generated table or ThinkSpeak, and these are the tables for this table right here, and it'll display that data. These are the sounds, and this is the major for loop that runs the whole simulation. More, if it's generated or ThinkSpeak, it will write that data into the respective value so that you can monitor the speed right here, and it'll turn on the speed alarm and the gauge. Now here's the color changer, so if it's visible from the above value, it'll allow the color to be changed. Otherwise, it will just display it as none or invisible on the screen. So if the visibility value is not displayed, then it'll say none, and those are none. Here is the plotting. So if we take the vessel color above, if it's none, then it's invisible again. Otherwise, it is the color that is selected, and then we use geoplots to plot it and geolimits to set the limits and then hold. And that is it for the code of the GUI.
Hello, my name is Kris Vera. I'm going to talk about the lane collision and bezel collision aspect of our app. So first, I generated values for markers along the section of the coast that we chose to center around. These markers simulate buoys in real life. I then used the geoplot function to display these values onto the map, as shown right here, and then created if-else conditions between each buoy and vessel, shown right there. Should it fall between the threshold, the alarm will go off, and the same case applies for the vessels. I define variables that calculate the distance between each ship, right there, and use a similar if-else condition to toggle the collision alarm. For our ThinkSpeak reach component, we have this table here. If we press the generate defaults button, it will load up values for each ship, and then the transmit function or transmit switch at the bottom of each table will then transmit these values onto ThinkSpeak. And then from there, we can load those values onto the app and start to display the ship. Here we have all the functions defined for each channel. And for each channel, we have one separate channel for each vessel.